Test. Mic testing. Test, mic test. Test, mic test. Okay. Okay, let's start our class. Okay, so our session will be recorded for these 2 hours. So make sure you already download the tutorial question if you want to follow along. So the tutorial question for chapter 1 you will see 12 pages. Okay, you can download from Canvas. So we already cover up to question number 7 because yesterday we cover a little bit about this chapter 1. Okay. All right. Now, yesterday we mentioned that for this module, we will cover metal, we'll cover composite, we'll cover polymer, we'll cover ceramic. And yesterday also we mentioned that we will look at the periodic table. So if you download the tutorial question, you will see periodic table, this one. So you will see a lot of time, you'll repeat a lot of time on periodic table. So make sure if can, you go and download the tutorial question or at least you understand what is periodic table. Okay. So in our module, we will discuss about material. Okay, we discuss about material. So we divide our material or element or substance into metal and non-metal. So in the exam, in your test 1 or test 2 or final exam, keyword, if you want to mention metal, then you need to use metallic, this keyword, metallic element and non-metallic element. Okay, yeah. So if you use metal, if you use the word metals, sometimes I give you marks, sometimes I do not give you marks. It's based on the question. Right. So all these you are familiar in your previous chemistry class. So these are examples for metallic element. So ferrum, copper, aluminum. So for this module, sometimes you need to do the reaction equation or chemical equivalent equation where you mix element A and element B. Remember, copper is Cu, it's not Co. Some students, they know they want to write copper, but in the equation they write Co. Then wrong already. It should be Cu, not Co. Nickel will come to nickel when we do alloying or metal alloy later. Okay. Titanium is a bit advanced material. Right? Okay, now we go into non-metallic material. So the one that you see on the screen, they are popular for this module. So you'll see a lot of example in this few examples. Just now, metallic material, you have these 5. Famous one is iron or Fe, copper, aluminum. These 2 later you will see when we go into alloy material. Right? Non-metallic, famous one is carbon, nitrogen, and oxygen. right? Non-metallic material. So for the beginning of this lecture, you have two major material, metallic and non-metallic, right? Now, yesterday I also mentioned the structure of the question will come out in the test and final exam. You have section A that you need to define, you need to tell what is it or something that you need to draw. So this will be the first section A. All right, give example of metallic element and non-metallic element. Right? So normally I'll ask you to give at least two examples, two or three. Okay, so this is all the answer that expected lah. Normally this kind of question will come out in your test 1 or test 2. Final exam, we won't ask you this fundamental question. Normally test 1 or test 2. Okay. Now we look at metallic metals, metallic element first. So when you talk about metallic element, the first technical word is crystalline structure. Crystalline structure, they link to metals. They link to metals. So what is crystalline structure? Definition for crystalline structure is the atoms arranged in orderly manner. Means there's a sequence or the way of arranging it. So when it comes to test or exam, I don't look at your grammar. I look for keyword, right? You can write in your own understanding, but make sure you mention the keyword. And you bring the meanings. Right? I can understand what you're writing, then you get the marks. Right? This is what you know for metals. They are good conductor for both electricity and thermal. So there are two chemical property here, thermal property and electricity property. Then later we'll go deeper, explaining why they are good conductor, why they are good thermal conductor. This is a very general things. So later we will link crystalline structure or the structure of element to mechanical properties or these two properties. Okay. So inside metallic elements, we can distribute another two. So one is, or two classes. One is ferrous, one is non-ferrous. Okay. Ferrous metals or alloy. Okay, metals here, the word here means pure element. Means pure element. If you see the word alloy means there's a mixture of one or more metals element. Okay, so we have two big classes here. One is ferrous, one is non-ferrous. Ferrous means you have the Fe element a lot. Percentage of Fe is a lot. Non-ferrous means you don't have Fe in the combination. Right? For example, aluminium. Aluminium fall under non-ferrous category or class. Although aluminium is a metals, but it fall under another classes because there's no Fe element. Copper, zinc, and so on. Okay, so these are two big classes. So that's why I mentioned just now, it is very dangerous if you use metals word in your answer. Right? So since we are studying about engineering materials, so be precise in the word that you use. Okay. So these are application on metal alloys on the aircraft. Yeah. Okay. Any question? Yeah. Yeah. Just try to capture the principle, the ideas. Right. Lots of things if you understand, then I'll just skip the next class. Yeah. All right. Don't worry about the PowerPoint slides. I will share with you later. Yeah. So in the class, as long as you understand the main point, then you're okay. So these are example on the application of material. Two big classes, again, ferrous and non-ferrous. Okay. So these are the blades, in the aircraft, gas turbines, and so on. Next, we have done for metallic element, we go into polymeric material or polymer, right, that you learn in your chemistry class. Okay. So basically, polymer or polymeric, it means it's a long chain. They're having a long chain of structure. And most of this material, they are non-crystalline. Means although they have a long chain, but there's no, sometimes there are no sequence. You cannot like say this is a cubic shape or this is a certain rectangular shape or polygon shape. You don't have a fixed shape for polymeric material. So normally they are structurally they are non-crystalline. Means you cannot define it as square shape or certain shape, because it's you can define only in a long chain. Okay. And so on. These are the mechanical properties. They are low density compared to metallic element. So okay. This one will come into place later. If you download the tutorial, you'll see a lot of graph later. So another term that we will touch is strength and ductility. Strength is how strong you can pull. Strength. Okay. Ductility is like glass. Will it able to break into pieces? Ductility, right? For polymeric, normally they are weak conductor in electricity and also thermal also, right? So later, these are the general properties of the material. Later, when we talk about structure, then we will link all these material properties back to the crystal structure or their structures. Example of polymeric is plastic. Okay, example. So one of it is what you learn in your chemistry class, C2H4, ethylene, or you call it hydrocarbon series. Hydrocarbon means it consists of carbon and hydrogen. Then you based on the numbers of carbon and hydrogen, you give it a name. So first one is ethylene, C2H4. So again, this kind of question will come up in the question section A, where you need to give example, you need to define what is that, then give example. So first one for polymeric is ethylene. And ethylene, then when you combine, it becomes polyethylene. Okay, so this is one example of polymeric material. So chapter 1 is just a general view. We won't go deep into the chemistry. Later on, there's a specific chapter in that particular topic. So chapter 1 just give you how we categorize material, what are the big classes, and then what are the specific significant features. Okay. Okay, so just to recap back, we have covered metallic, non-metallic, we cover polymeric. So can you differentiate or can you tell the significant features of metallic material? What are their mechanical properties? You can think of thermal conductivity and electricity, how good they are. Then you use the same point, explain polymeric material. Then how many classes you have for metallic materials? How you differentiate ferrous alloy or ferrous metals and non-ferrous metal? Can you give an example? Okay, so this is a few checkpoint for you. So let's back to the periodic table. Okay, so yesterday I explained about the row and column, the meaning of a row column. So here, those that polymeric normally polymeric famous one is carbon hydrogen. Normally those highlighted one, they can form polymeric material. Those in blue one. So H plus C, if 2 carbon, 4 hydrogen, you get ethylene, and so on. Silicon also can become a diamond plus oxygen and so on. So it becomes a diamond structure. Okay. Right. Okay. So first application of periodic table is those highlighted one. So in your own notes, you can do your own highlighting. Basically, what you do when you prepare for your final exam or test one, you only need to carry out some notes on the periodic table. Okay, these are examples for parametric, rubber shoes, and so on, right? So this one you can read from the slides lah. So we already give you example for PE. There's also PVC, PC, polycarbonate, polyester, and so on. So again, question will ask you to give 2 or 3 examples of polymeric material. Okay. So these are the few statistics data from textbook. There's increasingly usage of polymeric material. Right? This one you can read lah. But the idea is that the usage is increasing. Let's look at a few data from Rubber Council Malaysia statistics. This one is the latest one from their website. I extract from the website. So you can see, of course, this one is during COVID time. Of course, COVID time, you know, the glove is selling very good, right? But you can see the production of natural, synthetic, and consumption, production and consumption. Production, we do import rubber from outside, although we produce also, but we do import. But application of polymeric material is increasing from years to years. The idea is increasing, right? Then this one is another one. The rest you can read now. Okay, so this one is a Malaysia export, how we export the category of rubber that we export, natural rubber, synthetic, compound, reclaim, and so on. Or just in case you go into, when you do your internship later with rubber industry, maybe top glove, you go into top glove, then these are the general idea that you should understand. Okay, so yeah. So where we export, most of that is China. We export lots of to China. That's why our political relationship with China is very close. UAE also, Thailand also have. ROTW is mean rest of the world, rest part of the world. Okay. This other one you can read lah. Okay, so all these numbers, I won't ask you. Just give you some ideas what happening out there. You can see glove is actually the famous products out there. Okay. Okay, 22 minutes. You guys can continue. Yeah. Okay. So we have done metallic element, non-metallic element, including the polymeric material. Now we go into ceramic. Okay. So this one is question 21 in your tutorial if you download. Yeah. So what is ceramic? If you all are. Okay. So ceramic is inorganic material, but they are chemically bonded together. So it can be crystalline or non-crystalline mixture. The structure can be both. Okay, so this is the pattern of schematic diagram of the structure. Right. So crystalline Okay, this is the first diagram lah, that asks you to give definition of what is crystalline. Example, so normally this one very famous in final. If you give definition of crystalline, support your answer with a diagram or hand sketch, your understanding, right? So crystalline, it means you draw this diagram. So there's a pattern there. So the solid black one is metal item. Those white color cycle is non-metallic item. So they are linked with a sequence. There's a certain sequence there, right? The keyword is repeating pattern for crystalline. So another one is, this is a non-crystalline. You can see left and right diagram. So this is non-crystalline. It is because the pattern is unpredictable. The space between the ring there is unpredictable. Okay. Yeah. Okay. So crystalline and non-crystalline, there are two photos there. Right. Make sure you prepare that during your final exam question. Right. Yeah. Okay. Can I? Crystalline and non-crystalline. Non-crystalline keyword is irregular pattern or random pattern. Okay, so for crystalline, what I'm looking at is repeating pattern in this diagram, and then you explain what is the black color, what is the space cycle, and then you explain what is non-crystalline with the keyword atom in irregular or random pattern. Then you give one diagram, explain what is the black one and the circle, right? Yeah. So this is a video from YouTube about fiber optic. So I think this one you can watch online. Basically, all of you know what is fiber optic, right? So the video, I let it go home and watch it. One example of ceramic material is fiber optic. First, new term for you today is photonic material. So fiberglass, they are example of good photonic material. Keep this video. See how long? Yeah, 5 minutes too long. You go home and watch it. One thing that separates ceramic compared to polymeric material, try highlight the hardness. They have a high hardness, high temperature strength, but they are brittle. Okay, brittle is something linked with the ceramic material. Okay. Then under ceramic, you have two main classes: traditional and advanced ceramic. Okay. Traditional one is those clay products that you familiar with. Chemical component is important for this module. Example of traditional ceramic will be aluminum oxide, Al2O3, magnesium oxide, MgO, silica, SiO2. Okay, so still back to the periodic table just now, we highlight a few elements on the periodic table. So basically, it's a combination of the highlight element. Advanced is more, you use more additive. You use the additional chemistry, ceramic, you add some advanced chemistry there, right? You add this one, you add a few like resin, aluminum, and so on. So again, we expand the periodic table just now. So periodic table, we have metallic element. Light color one is those all these light color blue and dark color blue. Okay, so these 5 elements here, carbon, nitrogen, oxygen, P and S. So this is non-metallic, and then you mix them. Then it can be ceramic materials. So it can be fall under traditional ceramic. It can fall under advanced ceramic, right? Yes, you can. Okay, later before final exam, we'll look into semiconductor. What are the advantages? So you can read lah. Advantages of ceramic material. They are light. Their weight is very light. High strength. Good in heat resistant. Here is resistant. The word here resistant, not conductor. They are good resistant for heat. They also a good insulator. Okay. This one already explained. Again, there might be a question asking this one. Maybe 2 point or 3 point, ask you about ceramic material. Section 1. Section 1, definition. These are application of ceramic. Okay, most of it in engine, thermal, because they are good insulation. So something linked with the engine, then there is a ceramic there. These are a few examples of ceramic. So more advanced ceramic, we call it, one of it is ceramic matrix composite. Ceramic matrix composite. So this is under composite lah. This is 8 minutes. Also, this one you can read, watch at your home lah. Okay, ceramic we're done. We go into composite. So composite is your tutorial question number 28 lah. 27 start onwards. Sorry, 26. 26. So what is composite? Composite is you mix 2 or more material together, become a new one. Means it fall under composite. So in this, if you use this definition, it means that you can use metallic material mixed together, also can become composite. Right. The rest you can read. Most of the composite, you have a few elements there. First, you have a filler. Then you have a resin binder. These two, you need to use, normally you use filler and binder in composite material. Right? And the component, the properties for, if you use for composite, normally they do not dissolve in each other. Means they do not become something new. They just mix together, then they bond together, they become a new parts or new component. They are not chemically evolved into something new. Right? Meaning that you can still see the element if you cut them open and observe them under microscope. This is a composite material. Now we're talking about a composite material. Again, you have a few elements. So this is another diagram that you can draw and sketch. So it will be part of the assessment later. So what is composite consists of, or how you get a composite? You get fiber reinforcement plus matrix. Matrix, it means the glue or the resin chemistry. You mix them together, you become a composite. Okay, so this is, I think, the third diagram that possible come out from for your final or your test 1 or test 2. Something that you see that you can draw, then there's an area where we can ask you. Okay, so the rest is just elaboration, how they contribute to the final product's properties. If you want the properties have good strength, you can either choose a metric that have a good strength or filler or fiber that have good strength, either one. Then high stiffness and so on. These are the properties that you want. So you break the two element here, choose the properties, because some metrics, they cannot give you like high strength. Rubber cannot give you high strength. So you need to use another fiber or metals mixed inside there. They give you good strength. Okay, matrix material, these are the example. Just now the important is the diagram, this diagram. Then give some example of what kind of matrix that you can use. So there are 3 examples that you can use as a matrix. You can use as metal, ceramic, and polymer. So these are the 3 previous type of element that we discussed just now. Metal, non-metals, metallic element, metals, ceramic, and polymer. You can mix them as matrix material. These are the advanced composite. So if you use metal, then you name as a metal matrix composite. If you use ceramic, then it becomes ceramic, and so on. Okay. So when it comes to final exam, how we ask you? Okay, a company A try to is producing a polymer matrix composite for its customer. You as an engineer, you need to discuss with the floor about the process. First, discuss about the material or how composite is being formed. Explain using diagram. Yeah, for this case, this kind of question. So you draw the diagram just now. Okay, you draw the diagram. Draw this diagram and then name what this, what this, what this. And then based on the description, you fill in the blank. Like, okay, the customer want you to fabricate, produce polymer matrix composite. So you use polymer to produce the composite. So the rest you can read. Okay, the rest you can read. Important is these 3 things. How you differentiate metal, how you differentiate MMC, CMC, PMC. How you differentiate them, right? Important is on the matrix material that you use. Okay, this is another statistic that we won't ask you, but just let you see the trend of application of composite, especially this one is for the aerospace industry, the competition between Airbus and Boeing. You can see there's an up and down there. Composite used a lot in aircraft. Nowadays in automotive also. Right? Especially the introducing of the electric vehicle. It did become more light, become more and more light. Then composite is one of the solution. So these are the example on the aircraft where we use the composite. Right? So we have a glass fiber reinforced, quartz fiber reinforced, carbon fiber reinforced, metals and glass, and so on. So these are a few breakdown. Application of composite. This is on the automotive. If you break the car, so you can see actually our automotive products. They consist of lots of composite. Plastic is under polymeric material. Okay, steel, aluminum, steel. This one under metallic element. And so on. So what are example of a composite material? Fiberglass is one of it. So this is under microscope. Right? Microscopic means you watch it under, you see it under microscope. And the unit is usually 10 power negative 6 micron. In other textbooks, sometimes you see example of a composite, you see GFRP, glass fiber reinforced polymer. So this one, it can fall under polymeric material, but more correct one is under a composite. Right? Okay. Right. Before I go into semicon, you guys can still take it or you need break. 40 minutes already. You can take it? Can? Break. In the break? In the break? Okay, we break for maybe 10 minutes. Okay, we continue 250 lah. Okay, stop.